Module 8, hypothesis testing. This is one of the most important, chapters in statistics. Okay. Here we'll be learning the process of hypothesis testing. That is how we can use the information from the sample to predict about the population parameter. Okay, that's basically what we are doing in hypothesis testing. So in the first class, pretty much we'll be working on a lot of basic terms that is related to hypothesis testing. Okay, so you are going to see a lot of terminology, a lot of fundamental concept that we need to understand first before we actually start doing math. So that is what we are exploring today. You have everything in your note catcher, so you can follow along with me. First of all, what is hypothesis testing? That is something we need to know. When we say hypothesis testing, it is the statistical procedure in which the choice is made between null and alternative hypothesis based on the information in a sample. So as I was talking before, what will be given is you will have the information about the sample. Because from the very first chapter in this course in statistics, we know that it's not easy to get information about the entire population, right? What we do is instead we collect the data from the sample and we analyze that, okay? To get the information about the sample, what we'll be doing here in hypothesis testing is we'll be performing some statistical procedure, okay? We'll be performing some statistical procedure, or we are looking at some important steps there. Okay, we are looking at some statistical procedure. Basically, in hypothesis testing, you'll see that when you're doing this statistical procedure, it's going to be a 5-step procedure. Okay, those are the steps that we'll be following. So hypothesis testing is the statistical procedure. And after we perform the procedure, we make the choice between, okay, choice is made between null and alternative hypothesis. Choice is made between null and alternative hypothesis. So using the information given in the problem, okay, using the information given in the problem, we'll be forming two different hypotheses. We'll be forming null hypothesis and alternative hypothesis. We basically write null hypothesis like this. We write H sub 0, that's the null hypothesis, or H sub O, however you want to say, null hypothesis. And alternative hypothesis, it is written like this. H sub A, or sometimes we also write H sub 1. Null hypothesis is written as H sub O, and alternative hypothesis, it is H sub A or H sub 1. So one more time, if somebody asks you what is hypothesis testing, it is the statistical procedure, okay, where the choice is made between null and alternative hypothesis. Which one you'll be choosing? Are you going with the null hypothesis or are you going with the alternative hypothesis? And we'll do that based on the information that is provided in the sample. Okay. And in the problem, null and alternative hypothesis will not be given to you. You have to read the problem and you have to write your own null and alternative hypothesis. And when we say hypothesis, it is the conjecture about the population parameter. So whenever we are writing the hypothesis, it is all about the parameter. Okay, information about the sample will be given in the problem, but we are talking about the parameter here. In the hypothesis, we write the hypothesis about the population. Okay, we always write the hypothesis about the population, and then we'll decide whether we go with the null or alternative hypothesis at the end of the hypothesis testing or at the end of the statistical procedure. So you already know here from the definition, there are two different types of hypothesis, null hypothesis and alternative hypothesis. Okay, null hypothesis and alternative hypothesis. We'll talk a lot about null and alternative hypothesis in this course. So as I have shown you in the previous slide, you can see null hypothesis is denoted by H sub O. Let me highlight that, H sub O. And the alternative hypothesis is denoted by H sub A or H sub 1. And remember, null hypothesis, which is denoted by H sub O, is the statement about the population parameter that is assumed to be true. When we write null hypothesis, okay, when we write null hypothesis, we assume that the null hypothesis is true. But there's no guarantee that the null hypothesis is true. But we assume that it is true. And it is assumed to be true unless there is convincing evidence to the contrary. If we have some information to tell that it is not true, we always consider that the null hypothesis is true. Okay? And if we talk about the alternative hypothesis, it is a statement about the population parameter that is contrary to the null hypothesis. So alternative hypothesis is always contrary to the null hypothesis or opposite to the null hypothesis. Okay, alternative hypothesis, it is always contrary to the null hypothesis, and is accepted true because we consider the null hypothesis as true, and the alternative hypothesis will be true only if we prove the null hypothesis to be false. Make sense? And is accepted true only if there is convincing evidence in the favor of the alternative hypothesis. Now, here what we have seen is one very important thing that we have seen here is null and alternative hypotheses are opposite. But what is the general convention for writing the null and alternative hypothesis? We are going to look at that. So, for example, if we are talking about the null hypothesis, we may write null hypothesis like this. H sub O, null hypothesis. Remember, null hypothesis is about the population parameter, right? If we are talking about mean, so we'll talk a lot about mean and proportion here. So mean is equal to some value x. That value will be, obtained from the problem that is given to you. But here I'm just writing a general statement. You can see here in the null hypothesis, suppose the population mean is equal to mu. Remember, in null hypothesis, there is always equal to sign. In null hypothesis, there is always equal to sign. So you can also write that in your note catcher. Always equal to sign. So that means the alternative hypothesis will have 3 different signs. What are the 3 different signs that are opposite to that? Let's see. Alternative hypothesis can be this one. H sub O, alternative hypothesis can be mean, population mean, not equal to x. Right? That is the opposite of that. Do you see that? If here we say that mean is equal to x, x can be 10, x can be 12, x can be any number here, right? The alternative hypothesis will be mean is not equal to x. That is one possibility. Or the other possibility is, or we can also say that this is alternative H sub A. Alternative hypothesis will have mean may be greater than x, right? It's equal to for the null hypothesis, so it can be greater than. Or the other possibility is, now you can easily tell what is the other possibility, what it is. Less than. Mean is less than x. So you can see that there is no equal to sign in case of alternative hypothesis. These are all inequalities. Less than, here is less than, then we have the greater than, then we have the equal to sign. So there is no equal to sign. It has all inequalities. So you can see that alternative hypothesis, 3 possibilities. 3 possibilities with no equal to sign. With no equal to sign. Because they are inequalities. Remember, when you're solving the actual problem, you don't have to write all these 3. Depending on the question, okay, you just need one situation. It may be not equal to, it may be equal to, or, it may be not equal to, it may be greater than or less than. So make sure you write all those additional things that I'm writing here on the slides, because these are very important information. Any questions so far? Okay. Let's move on to next slide here, and how to write the null and alternative hypothesis. We have a little bit idea already how we can write the null and alternative hypothesis. Okay, and here is the guidelines and some additional information here. So to write the null and alternative hypothesis, what do? Test procedure is based on the initial assumption that the null hypothesis is true. After we write the null hypothesis, right? After we write the null hypothesis, we consider the null hypothesis to be true, but it is not the fact. We have to prove it by performing those statistical tests. Okay. Second thing, null hypothesis contain equality sign. Null hypothesis has equal to sign. Like here, I have 3 different cases here. In all of them, null hypothesis, you can see null hypothesis, mean is equal to K. In my example in the previous slide, I use X, right? It can be any value. So just like that, mu equal to K, it always has the equal to sign. Whereas the alternative hypothesis, because it is opposite of the null hypothesis, it may have not equal to sign, it may have greater than sign, or it may have less than sign, as I have shown here in the table, right? So based on that information, if you look at the first column here in the table, what you'll see is if there is not equal to sign in the alternative hypothesis, okay? If we have not equal to sign in the alternative hypothesis, the hypothesis test that we'll be performing there, its direction will be two-tailed. It's called the two-tailed test. Okay, that is called the two-tailed test. Two-tailed test. Let me underline that. It's called two-tailed test. When there is not equal to sign with the alternative hypothesis, then we call it two-tailed test. That means in two-tailed test, your rejection reason will be on two tails. Okay, your rejection reason will be on two tail. That is, if the parameter lies in the tail, on the left tail and on the right tail, then we reject the null hypothesis. So rejection reason will be on the tail. So we can show it like this. So little area on the left, little area on the right. Okay, that reason is the rejection reason. Rejection reason. Let me write RR in short. Rejection reason. So if the parameter lies on the tail, then the null hypothesis will be rejected. Or I can say, if the test value lies on the tail, then the null hypothesis will be rejected. Remember, if we reject the null hypothesis, the other hypothesis is not rejected. We fail to reject the other one. We fail to reject the alternative hypothesis. So that means this reason in the middle, this one, it is called the acceptance reason. The reason in the middle is the acceptance reason. Let me write it down. The reason in the middle is acceptance reason. In case of the right tail test, which I have shown here in the second column, as you can see, it's called the right tail test because, look at the alternative hypothesis, because alternative hypothesis will tell you which test is it, left, right, or two tail. So here we have X is greater than K. Greater means larger value, right? And if you think of this number line, which is underneath the graph, you will have the bigger numbers on the right, right? The larger numbers will be on the right. That's why it is called the right tail test. And the rejection reason will be on the right. Okay, rejection reason will be on the right tail. So we can show that rejection reason on the right tail. So that is the rejection reason. I'm going to write R for rejection reason. Everything else, that is the acceptance reason. Everything else is the acceptance reason. So if the test value, when you're performing the right tail test, if the test value lies on this right tail, where I have shown in red here, then the null hypothesis will be rejected. Okay. But if it is over here in the acceptance reason, we fail to reject the null hypothesis. And now you have the idea about the left tail test. So in the left tail test, you can see in the alternative hypothesis, we have less than sign. So lesser numbers are on the left. That's why the rejection reason is also on the left tail. Rejection reason is on the left tail here. That is your rejection reason, and acceptance reason is everything else. So one important thing that you need to understand from this slide is when you're performing the hypothesis testing, we have to follow certain directions there based on the alternative hypothesis. As I have shown here in the first column, the alternative hypothesis has not equal to sign. Okay. If there is not equal to sign, then the rejection reason is on both tails, and we call it two-tail test. Okay. Here in the right, in the second column here, this is the right tail test because we have mean is greater than k, greater numbers are on the right. That's why the rejection reason is on the right tail. Okay. And the last one in the third column here, left tail test, because we have mean is less than k as the alternative hypothesis. And we know that the lesser numbers are on the left, right? That's why the rejection reason is on the left tail. So when you look at the test, okay, there are several ways we can perform this hypothesis testing, but we'll always be looking at whether it is two-tail test, right tail test, or left tail test. Remember, how we determine this is by looking at the alternative hypothesis. Okay, by looking at the alternative hypothesis. In fact, the hypothesis will not be given to you in the problem. You have to read the problem and write the hypothesis yourself. So you can think of these problems as very serious problem, because first you have to read the problem, right? You need to understand the problem. Based on the information, you are writing the null and alternative hypothesis. Okay, you have to write this hypothesis correctly. If you happen to write the hypothesis incorrect, the next step is going to be wrong, because in next step what you're doing is, based on the alternative hypothesis, you are determining whether it is two-tail test or one-tail test. If there is not equal to sign in the alternative hypothesis, two-tail test. If it is greater than in the alternative hypothesis, right tail test. If it is less than in the alternative hypothesis, left tail test. Okay, you have to remember that much. Any question before we move on? We don't use less than or equal to, because equal to is exclusively for null hypothesis. Okay. Okay, let's move here. Now, let's talk about the error in hypothesis testing. Sometimes we perform the hypothesis testing and we get the wrong information. If we get that wrong information, we call it error in hypothesis testing. Okay, we call that error in hypothesis testing. And we label this error as type 1 error and type 2 error. Okay, we call it type 1 error and type 2 error. So we need to know what is type 1 error and what is type 2 error. For example, in type 1 error, if you reject the null hypothesis, look at the statement given. If you reject the null hypothesis when it is true, so you have the null hypothesis, let's write here, you have a null hypothesis, you have the alternative hypothesis. Say, for example, null hypothesis is true and alternative hypothesis is false. Suppose that is the case. Null hypothesis is true and alternative hypothesis is false. Null is true, alternative is false. But what you are doing is, if you reject the null hypothesis, in fact, if the null hypothesis is true, you are not supposed to reject that, right? But by mistake, if you reject that, you reject the null. You reject the null and you go with the alternative. If that happens, then this is called type 1 error. This is called type 1 error. So it was written in sentence. Now I just use the symbols to write the same thing. If you reject the null hypothesis when it is true, it's called the type 1 error. Or symbolically, I wrote null hypothesis true, alternative hypothesis false. It was true, you are supposed to accept that. You are not supposed to reject that. But what is going on here is you are rejecting. Do you see? I cross that, right? I'm rejecting that. If that happens, that's called the type 1 error. And you can also see here, I have shown here in the table down here. If you look at the type 1 error, which I have shown here in red color, and I wrote false positive. Okay, I've written false positive. What is going on here? See, null hypothesis is true. Null hypothesis is true, but what's going on there? We reject the null hypothesis, right? If that happens, that is called the type 1 error or false positive. Remember, type 1 error is not that dangerous. Not that dangerous. For example, let me give you an example based on our experience during the pandemic. For example, you had a fever and then you want to go and get that COVID test, right? You want to go and get that COVID test. Say, for example, the test came out positive. Test came out positive, but you actually don't have the virus. That happened to many people during pandemic, right? You don't have the virus, but the test come out to be positive, and now you are like, okay, I have COVID. And what you have to do is during that time, we used to stay in isolation, right? To protect everyone else. So we just used to sit isolated from everybody so that we cannot spread this. But remember, even by mistake, you are not there in isolation and you are with other people, you'll not be transferring any disease there because you don't actually have the virus, right? Because the result was false positive. So the false positive result, we call it type 1 error. Okay, so type 1 error is not dangerous because you don't have virus even if you don't isolate there, right? Now let's look at the second one, type 2 error. So in type 2 error, look carefully, you do not reject the null hypothesis when it is false. Okay, null hypothesis is actually false and alternative is true. Alternative is true. So if the null hypothesis is false, listen carefully, if the null hypothesis is false, are we supposed to reject this or not? We are supposed to reject it, right? But there is a mistake. We are not rejecting this. That means we are accepting it. We are accepting the false. That means this type of error is called type 2 error. Type 2 error. And also I have shown here type 2 error here in the fourth box in the table. As you can see, type 2 error, it's called the false negative. False negative. Remember, this is dangerous. False negative is dangerous. If you take the same example of doing that COVID test, you actually have the virus. Say, for example, you actually have the virus, but when you do the test come out to be negative. Then you don't have to go for isolation, right? You may be wandering around. And what you are doing at the same time, you are also spreading the disease. So it's dangerous, okay? Type 2 error is more dangerous compared to, in fact, type 2 error is dangerous and type 1 error is not that dangerous, right? And other two cases in this table, they are the correct outcome. For example, null hypothesis is false. That means you reject the null hypothesis. That is the false, that's the correct way of making decision. Or if the null hypothesis is true and you fail to reject, then that is also the correct outcome. Okay, but those two are the error. Null hypothesis is true, but you are not accepting it, type 1 error. Null hypothesis is false, but you are accepting that hypothesis. That means that is also the error. So you should actually know the difference between type 1 and type 2 error. If you get a short question in the quiz or the test where you have to select between the type 1 and type 2 error, you must know this basic one. If you just remember the symbolic formation that I have written here, that will be easy. Or if you can remember from the table, that's also easy. Remember, one more time, type 1 error is called the false positive. Type 2 error is false negative. Okay. If you have question, you can ask me. If not, now we are kind of ready to perform at least one type of hypothesis testing. Okay, so there are several different methods. Okay, there are several different methods of performing the hypothesis testing, several different methods. But the first one is called the p-value method. Okay, first way of performing the hypothesis testing, it's called the p-value method. And today we are going to explore p-value method. And you know that hypothesis testing is the statistical procedure where the choice is made between null and alternative hypothesis, right? We already know the definition. So we are going to look at the procedure here. What are the steps? Okay, so 5 steps for p-value method. So I have these steps listed out here. You actually need to remember these steps for the test, because in the test, I'll provide the formulas, but not the steps, right? So you need to remember these steps. So what do we do? Look at this. Problem will be given to you, just like, let me show you here, just like this one here, okay? Problem will be given to you. What you have to do is you have to read the problem first, and then you have to identify the claim. What is the claim? Okay, what is the researcher claiming in the problem? You have to look at the claim and then state the null and alternative hypothesis. So in first step, what you're doing is, basically in first step, let me write. In first step, you'll write what is null hypothesis. You'll write what is alternative hypothesis. And then from this, you have to select which one is claim. Is the null hypothesis claim or alternative hypothesis is claim? You have to find it out. And then based on the alternative hypothesis, you have to decide whether it is one tail test or two tail test. After that, you'll decide one tail or two tail test. One tailed or two tail test. That is something you have to make ready in your first step. Read the problem, write the null and the alternative hypothesis, decide what is the claim, and then you have to find out whether you are doing one tail test or two tail test, and using what method. Of course, in this one, we are doing the p-value method, but later on, you should also be able to determine which method you are using it. And especially in our course, I'll just mention which method you'll be using. I'll write in the problem whether you are using the p-value method or the critical value method or the confidence interval method. I'll mention that in the question. Okay, so that will be quite easy for you. Now, once you write the null and the alternative hypothesis in your first step, your second step is to calculate the test value. Okay, second step is to calculate the test value or test statistics. Second step is to calculate the test statistics. Okay. And in order to calculate the test statistics, what you do is, there's a special way to find the test statistics. Remember, in order to calculate the test statistics, test value will be equal to, okay, test value is equal to, you'll use the value from the sample, which is called the statistic minus parameter, statistics minus parameter, and you divide that by the standard error. And we already know how to find that standard error in the previous chapter. So in order to find the test statistics, we use the formula, statistics minus parameter over the standard error. Make sure you add all those information in your note catcher, because these are the steps that you'll use when you're doing your homework, when you're doing your quiz, when you're doing your test. Then once we have the test value, next thing we have to do is we have to find the p-value, because this is the p-value method. You have to find the p-value. P-value, and in order to find the p-value, we'll be using calculator. And remember, p-value is the area in the rejection or the tells, because we already know over here in this step, in the first step, once we decide whether it is two-tell test or one-tell test, we know where that reason is, right? Whether it's in the two-tell or in one-tell, left tell or right tell, that area in the rejection reason is the p-value. Okay, p-value is that area in the rejection reason. So make sure you underline that so that you can remember it. P-value is the area in the rejection region or the tail region. So you'll actually draw the diagram and then you'll find that area in the tail region. And once we have that, now the next step is the time to decide whether you can reject the null hypothesis or fail to reject null hypothesis. What you'll do is in next step, you'll compare the p-value with the significance level alpha, which will be given in the problem. You know the alpha from the previous chapter when you're working on the confidence interval. The confidence level is the area in the middle, if you remember, right? C is the value in the middle. The remaining area is the alpha, right? Which we divide on the tail, that was alpha. That's the significance label. So significance label will be given in the problem. And what you have to do is, in third step, you get the p-value. You compare the p-value with alpha. Okay, when you say compare, you are checking which one is bigger and which one is smaller. Okay, if the p-value is less, if the p-value is less than or equal to alpha, if p-value is less than or equal to alpha, in that case, we reject the null hypothesis. Null hypothesis will be rejected. That means we fail to reject the alternative. And then if p is greater than alpha, we fail to reject the null hypothesis. So because we make the choice between the null and the alternative hypothesis, we want to see first, because we assume that the null hypothesis is true, right? That is where we begin. We assume that the null hypothesis is true. So once we perform the test, then we can check whether we can reject the null hypothesis or we fail to reject the null hypothesis. And once you do that, then at the end, we can make the statement about the hypothesis testing. We can write the result of the hypothesis testing as our conclusion. Okay, so at the end, we end the process using the conclusion. That's the, we state the result of our hypothesis testing. So these are the 5 steps. Okay, just by looking at these 5 steps, and when I'm just talking through these, it will not make a lot of sense. That's very true. But once we start working on the example problem, this will be more meaningful. Now, p-value method, remember, p-value method can be used for several different types of hypothesis testing. But one important thing that you have seen from your module 6 and module 7, we talk about 3 different cases of central limit theorem, if you remember, right? We also talk about 3 different cases of confidence interval in module 7. When we're talking about module 7, what we said is, if the population standard deviation is given, if you remember, if the population standard deviation is given, the sampling distribution will follow standard normal distribution, right? We calculate the z value there, z critical. And if the population standard deviation is not given, we calculate the t critical, because the sampling distribution will follow t distribution, right? That's still true in this chapter also. And for proportion, it is always the standard normal distribution. We calculate z value there. Okay, so here also we'll be doing that. We'll be doing the z test and also we'll be doing the t test. Okay, so this one is z test for mean. So z test will be for mean and also for proportion, because if you remember from chapter 6 one more chapter 7 one more time, when the population standard deviation is given, standard normal. For the proportion, it is always a standard normal, right? Standard normal means Z distribution. So Z test is for mean and also for the proportion. But this one, the first one that we are looking here is the Z test for mean. So the Z test for mean is a statistical test for the mean of the population. It can be used either when n is greater than or equal to 30. So if you remember from the central limit theorem, what we know is if n is greater than or equal to 30, right? That is this portion, we get this from the central limit theorem. If n is greater than or equal to 30, the sampling distribution of sample mean is always normal, right? That's why n is greater than or equal to 30. Or if the population is normally distributed, the sampling distribution is always normal. Population is normally distributed. In both cases, this is what we get from central limit theorem. In both cases, whether n is greater than 30 or population is normally distributed, in both cases, the sampling distribution of sample mean is normal, right? So it follows the normal distribution. And on top of that, the population standard deviation will be given to you. And when the population standard deviation is given, it follows the standard normal distribution. It's not just normal. In fact, it is standard normal distribution. And this is the formula for the test value. If you remember in the previous slide, what I wrote there, test value is equal to statistics minus parameter over standard error, right? That's what I wrote. Let me also write here, test value. You can also add if you want. Test value is statistics minus parameter over the standard error. That is the standard formula. But in this case, this is the Z test. So this is the Z test for mean. See, we are talking about mean. So in place of statistics, it will be sample mean. So X bar in our formula. Parameter is the population mean, so mu. And standard error, you already know that the standard error for mean, when n is greater than 30 and population is normally distributed, is the population standard deviation over the square root of n. So sigma over square root of n, that is the standard error. So in your formula sheet later on, this formula will not be given. Instead, this one, the general formula will be given. Test value is equal to statistics minus parameter over standard error. So depending on the situation, you have to write your formula correctly. So in this case, Z test for mean, this is the correct formula. Okay. Okay, I know you are so much ready to look at the example. So now let's look at the example here. And here we are going to follow those 5 steps to solve the problems. First step, is to read through the problem, not just read thoroughly, right? Here we are not just reading the problem because we need to read. We are reading the problem because we need to understand the problem, right? That's very, very important. So could you please quickly read the problem for yourself? Okay, so let's see. The problem says, a professor wishes to test the claim that average cost of tuition and fees at a 4-year public college is greater than 5,500. He selects a random sample of 49 4-year public colleges and finds the mean to be 5,850. The population standard deviation is 650. Is there evidence to support the claim at alpha equal to 0.05 or 5% significance level? So probably you have seen that there is a claim. This professor is making a claim. What is he doing? A professor wishes to test the claim that the average cost of tuition and fee at 4-year public colleges greater than 5,500. That's what he's saying, right? He's saying that the average, he's talking about the general population. So average is greater than 5,500. 5,500, that is the claim. And he wishes to test that claim, whether his claim is true or not. That is the information about the population. And in order to do that, what he's doing is he selects a random sample of 49 public colleges. So you can see N equal to 49, 4-year public colleges. And you can see that N is greater than 30. Do you see that? N is greater than 30. That means the sampling distribution of sample mean will be normal. And for that 49 4-year colleges, he found the average tuition and fee to be 5,850. That is the average of the sample. Average of the sample, X bar. And the population standard deviation is 650. See, population standard deviation sigma is given. Population standard deviation sigma is given. Now, look at this last part. This is important. Is there evidence to support the claim at alpha equal to 0.05? Nowhere in the question they will say perform the hypothesis testing. Instead, they will ask you whether there is evidence to support the claim or not. That's the way of asking this question. So from here, is there evidence to support the claim at alpha equal to 0.05? This is telling us to perform the hypothesis testing, okay? And what we are doing here is we want to use p-value method because that's what we are learning now, right? But in the test or the quiz, the method will be specified. But this one is under the topic p-value. So we are doing the p-value method here. So what is our first step? What do you have to do? We have to state the null and alternative hypothesis, right? So we have to write null hypothesis. This is about mean. We are talking about mean. So average is equal to how much? And then the alternative hypothesis, average in the problem. Look at the problem. In the problem, we already have average greater than 5,500 as the claim, right? That is the alternative because alternative will have the inequality sign. Alternative will have the inequality sign. We wrote that. And we also know that this is the claim. That is our claim. So we write that as our claim. That's our claim. What will be the null hypothesis? Null hypothesis will have equal to sign, right? So here we write mean equal to, it's opposite of this one. So mean equal to 5,500. Mean equal to 5,500. Okay, once we know this, once we write the null and alternative hypothesis and also the claim, we have to tell which test is this. Is it one tell test or two tell test? The null hypothesis has equal to sign always, but alternative hypothesis here has greater than sign. So what type of test is this? Is it two tell test, left tell test, or right tell test? Right tell, because we have the greater than, right? So we'll write that. This is right telled. Now listen. Okay, this is right telled. Here we are talking about mean. Okay, here we are talking about mean, as you can see. And also what we know is the population standard deviation is given. If the population standard deviation is given, it's going to follow the normal distribution, right? If it is going to follow the normal distribution, then we say that it is the z-test, right? So this is right-tailed z-test for mean. We are talking about mean or average. That is your first step. Okay. So in first step, we wrote the null hypothesis, we wrote the alternative hypothesis, we selected the claim, we also decide what type of test is that. It's a right tail test, and we are using the z-test for mean. And we are following the p-value method, obviously. That is our first step. What is our second step? You can look at your notes and tell me what is our second step. calculate the test statistics. That is right. Now let's find the test statistics here. I'm using different color for next step so that you can clearly see these steps. So Z equal to, because this is a Z test, so Z is equal to, statistics is going to be mean here. Parameter is the population mean. Over standard deviation, it will be sigma over square root of n. So plug in the values. Average of the sample is 5850. Average of the population, which will be there in null hypothesis, 5500 over population standard deviation 650 divided by square root of n, square root of 49. Now you can type this information in your calculator and find the value of that test statistics. Please use your calculator. What do we get? No. Make sure you put parenthesis around the numerator or you use the fraction bar. Okay. You said 3.7692? 3.7692. Make sure you use the fraction bar so that everything will be correct. Alpha y and then enter in your calculator, in TI-84 calculator to get that fraction bar. Alpha y and then enter to get that fraction bar in TI-84 calculator. Did you find it?
Why?
Alpha y. Oh, you don't have it. Your calculator needs an update. So you have to type it like that.
Oh, I got it.
Also put the parenthesis around the denominator.
Oh.
Okay, 3.7692. That is correct. Everybody got that? So you see, we did the two steps. First step is writing the null and alternative hypothesis, deciding what is the claim, and also deciding whether it is one tail test or two tail test, and whether we are doing the Z test or T test. Here we are doing the Z test. And because we are doing the p-value method, the second step is to find the Z value, that is the test value. We got that test value. What is our third step? Find the p-value. And you know that p-value is the area on the tail, right? P-value is the area on the tail. So what we have to do is we have to draw that normal distribution. So let's draw the normal distribution in our third step. Okay, suppose that is my diagram here. So this is the normal distribution with mean 0 and standard deviation 1, 0 in the middle, Z values along the x-axis. And what you have to do here is we have to show the rejection region. This is a right tail test. That means we have to show the rejection region on the tail, on the right tail. So this one here, this is the rejection region. And what is the area on the tail called? It's the p-value. Okay, that is the p-value. We have to find that p-value. And if you look at this diagram carefully, what you know is because you are calculating the area, right? Because you are calculating the area, in your TI-84 calculator, you'll use normal CDF, right? Normal CDF. And then we need a lower boundary here. What is that lower boundary? We go all the way up to upper boundary. But do you know what is the Z value along this x-axis? This is the value that you have calculated there, right? Okay, so we write that value. So let's write that value. That is 3.7692. And your P will be equal to normal CDF 3.7692 up to infinity, mean is 0, standard deviation is 1. I hope that makes sense, right? We have the Z value, the test value from step 2. We use that value here, and we want to find the P value, that is the area on the tail, because that is the area. To calculate the area or probability, we use normal CDF. Lower boundary 3.7692. We go all the way up to infinity. Mean is 0, standard deviation is 1. So please type that in your calculator and tell me what you will get. What do we get? Because this is the Z test, right? Because the population standard deviation is given. So when you know the population standard deviation, the distribution of the sample is standard normal. For the standard normal distribution, mean is 0 and standard deviation is 1. And you have Z value along the x-axis. That's why. We'll use something else, yeah. Yeah, but for hypothesis testing, it's going to be standard normal, always, yeah. Okay, what do we get? Do you get something interesting? 0.008? 0. Oh, there is -5 at the end. Okay, there is -5 at the end. That means 0.40. Let me write it down. 0.1, 2, 3, 4 zeros. And then what are the numbers after that? What are the numbers there? What do you see? 8992. Yeah, okay, 819912. Okay, if I just want to round it to 1 decimal place, then it will be, as you said, 0.1, 2, 3, 4 zeros and then 8, right? You can write like that, 0.4 zeros and then 8, because you get a -5 at the end. So you'll have 0.4 zeros. So we got that area. So you can see that that area is really, really small. Okay, that area is really small, 0.4 zeros and then 8. That's our third step. And if you look at my writing here, I am using different color for different steps so that you can easily see I'm following those 5 steps. First step here, right, where we have the null and alternative hypothesis. Second step, we calculate the test value. Third step, using that test value, we calculated the P value. What is our fourth step? What do we do in fourth step? We compare, that's right. So here, if you compare the P value, what do you find? Do you find that P is this one, the area that we got, is that P greater than alpha or less than alpha? What do you see? Less, right? Because alpha is 0.05. So P is less than alpha. And so here P is less than alpha. So if it is less than alpha, do we reject the null hypothesis or fail to reject? What do you have in our notes? Reject. Okay, P is less than alpha. So this implies null hypothesis. Null hypothesis is rejected. Null hypothesis is rejected because P is less than alpha. Null hypothesis is rejected. And I am going to do that using a red color here. And then I'm going to reject the null hypothesis. I'm going to cross out the null hypothesis. Null hypothesis is rejected. So null hypothesis rejected. Do you see that? Because hypothesis testing is the statistical procedure, this all process that we have done. This is the hypothesis testing, okay? It is the statistical procedure where the choice is made between null and alternative hypothesis. So we reject the null hypothesis. So we go with the alternative hypothesis, right? So I'm going to put a check mark with the alternative hypothesis. So I'm going with the alternative hypothesis. Are we clear up to here? Okay, so what is the meaning of that then? If you look at this one here, where we have cross and check, we put the check with the claim. That means what we say is there evidence to support the claim? Yes, right? We are supporting the claim. Do you see that? We are supporting the claim. So our conclusion, last step will be, hence there is enough evidence to support the claim. And our claim is average cost is greater than 5,500. Okay. Average cost of tuition and fee at four-year college is greater than 5,500. That was the claim. And we are saying this at 5% significance level. So we'll write that conclusion. So let's write it down. That's our fifth step. Hence, there is enough evidence to support the claim. I'll write that claim in the parenthesis. Mean is greater than 5,500. And we are doing this at 5% significance level. Hence, there is enough evidence to support the claim that the average cost of tuition and fee at four-year public university is greater than 5,500 at 5% significance level. So this is how we can use those 5 steps to solve the, hypothesis testing problem. Okay, and you can clearly see when we have started with first step and when we come to fourth step, and when we make that decision, you have clearly see that we make the choice between the null or the alternative hypothesis, right? So one more time, as the definition suggests, hypothesis testing is the statistical procedure. We perform the statistical procedure and we are able to make the choice between the null and alternative hypothesis. Remember, the method we have used here is the p-value method. Okay, p-value method using z-test. Method is p-value method. The test we use is the z-test for mean. Okay, so you have to know which method you are using and which test you are using. Test will be z-test and t-test all the time. Okay, test will be z-test or t-test. Today, in this example, we use the z-test because the standard deviation is given. If the standard deviation of the population is given, that will be z-test. If the standard deviation was not given, if the population standard deviation was not given and sample standard deviation was given, it would be t-distribution and it will be t-test. Okay, and method can be still p-value method. So basically, we are looking at 3 different methods: p-value method, okay, critical value method, and confidence interval method. We'll be looking at 3 different methods and 2 different tests: z-test and t-test. Z-test can be for mean or z-test can be for proportion, and t-test is always for mean. T-test is always for mean when the population standard deviation is not given. Instead, the sample standard deviation is given. So I think that's all we are doing today. But it's not yet time for you to go. Let me stop recording quickly.